Now today we see the remaining examples in the exercise 2.2. We have discussed the 9 examples. Now the example number 10. Okay. If Sn, S2n and it is S3n are the sum of n, 2n and 3n terms of a geometric progression respectively. Then verify that here Sn into S3n minus S2n is equal to S2n minus Sn whole square. Here it is Sn, S2n and S3n are the sum of the terms in a geometric progression. Okay, here. Now listen, it is let it is A be the first term and R be the common ratio in geometric progression. Okay, here A is the first term and R is a common ratio. Therefore, we know that the sum of the n terms, we know formula for the sum of the n terms. Therefore, we can write it is a Sn is equal to A into R to the power n minus 1 upon R minus 1. Here it is a formula for the sum of the n terms. Okay, when the R is less than 1 or greater than 1 is not indicate, we use this formula for the sum of the n terms in a geometric progression. Okay, it is Sn, but here 3 sums are the given: Sn, S2n and S3n. Okay, therefore from this we can write S2n is equal to A into R to the power 2n minus 1 upon R minus 1 and S3n is equal to A into R to the power 3n minus 1 upon R minus 1. Okay, it is the sum of the n terms, it is the sum of 2n terms and it is the sum of 3n terms. Now we want to verify this expression here. Sn into S3n minus S2n is equal to S2n minus Sn whole square. Okay, now first we find the value of this LHS. Okay, now we find it is Sn into S3n minus S2n. Okay, here see carefully this Sn it is this A into R to the power n minus 1 upon R minus 1. Okay, into this S3n, it is S3n A into R to the power 3n minus 1 upon minus A into R to the power 2n minus 1 upon r minus 1. Okay, here it is Sn, it is S3n, and it is S2n. Now we calculate. First we calculate this bracket. It is as it is, a into r to the power n minus 1 upon into, see carefully this, here in this a upon r minus n, a upon r minus n take common. It is a upon r minus 1, a upon r minus 1, a upon r minus 1, then into this is r to the power 3n minus 1, and here it is minus r to the power 2n, and it is a plus 1, minus, it is minus and it is plus. Okay, now then it is as it is, a into r to the power n minus 1 upon r minus 1. See carefully in this bracket, here it is as it is, a upon r minus 1, and in this bracket this minus 1 and plus 1 get cancelled. We write r to the power 3n minus r to the power 2n. Okay, only we cancel this plus 1 and minus 1. Okay, now here it is r to the power 3n and it is r to the power 2n. In these two terms we can take common r to the power 2n. It is r to the power 2n and it is r to the power 2n, means 2n, it is r to the power 3n, means r to the power 2n plus n. That means this r to the power 3n can be written in the form r to the power 2n into r to the power n. Okay, here. So we take common r to the power 2n. Okay, see carefully this. Therefore, this can be written this Sn into S3n minus S2n is equal to a into r to the power n minus 1 upon r minus 1. This a into r to the power n minus 1 upon r minus 1. Then this bracket. Here a we can take common r to the power 2n upon r minus 1. A upon r minus 1, and in this bracket we can take the common r to the power 2n. Then in this bracket remaining it is r to the power n minus 1. When we common r to the power 2n, here it is 1, and in the common we take the r to the power 2n, then here it is remaining r to the power n. This, and then the calculation of this term is here a into a, it is a square, then r to the power 2n, and into r to the power n minus 1 square, r to the power n minus 1, r to the power n minus 1, and whole to the upon r minus 1 whole square. It is the value of this RHS. Sorry, it is LHS. Okay, we take this is equation number 1. Now we find the value of the RHS, and it is S2n minus Sn. S2n minus Sn whole square, and then this can be written as S2n, it is S2n, a into r to the power 2n minus 1 upon r minus 1 minus Sn, it is Sn, a into r to the power n minus 1 upon r minus 1. See carefully, here denominator is same, so we subtract the numerator. Okay, now it is a whole square, it is a square, so we can write this is whole square. Now here we take, it is a upon r minus n, a upon r minus 1, and it is a upon r minus 1 common, like this. Okay, here a upon r minus 1, then in bracket r to the power 2n minus 1 minus r to the power n, and it is a plus 1. Okay, whole square. Okay, same calculation as this. Okay. Again here plus 1 get cancel, and here it is a upon r minus 1, and here in this it is r to the power 2n minus r to the power n, it is a remaining whole square. Then it is a and here r to the power 2n and it is r to the power n. We can take r to the power n common, therefore r to the power n, okay, upon r minus 1, and into here it is r to the power n minus 1 and whole square. See carefully this. It is equation number 1 and it is equation number 2. When we take the whole square, here it is a square into r to the power 2n, r to the power n square, it is r to the power 2n into r to the power n minus 1 square and whole to the upon. It is equation number 2, and from equation number 2 and 1 and 2, see carefully, it is verified, both are the equal from 1 and 2. From 1 and 2, it is Sn into S3n minus S2n is equal to S2n minus Sn whole square. It is verified. Okay, see carefully the calculation. It is a Sn, S2n, S3n. In the LHS, Sn into S3n minus S2n. Okay, Sn, S3n, and it is S2n. And we take the calculation, we get the value of this. It is a LHS. Okay, and it is RHS, and both are the same. Okay, therefore it is verified. Sn into S3n minus S2n is equal to S2n minus Sn whole square. See carefully the calculation. Okay. Now next example. Example number 11. Find number 1 sum of the 10 terms, that is r is equal to 1 to 10 3 into 2 to the power r. We want to find this sum. And the second example, again sum of the 10 terms, r is equal to 1 to 10 5 into 3 to the power r. Now here it is a sum, it is symbol for the summation. Sum of the 10 terms, that is r is equal to 1 to 10, that means 3 into 2 to the power 1 plus 3 into 2 to the power 2 plus 3 into 2 to the power 3 up to 10 times. Okay, here the first example, here it is given, it is sum of r is equal to 1 to 10, it is a 3 into 2 to the power r. See carefully this, it is a 3 into, we can take this 3 constant, it is outside the summation, 3 into sum of r is equal to 1 to 10 of 2 to the power r. Okay. Here 3 is a constant, 3 into 2 to the power r, here 3 into sum of 2 to the power r, where r is equal to 1 to 10. Okay, here this summation we can express as a sum. See carefully this, here 3 into 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 plus and so on up to 2 to the power 10. Okay, now here it is a series. Okay, 2 plus 2 square plus 2 cube plus 2 to the power 4 plus 2 to the power 5 up to 2 to the power 10. Now see the sequence. It is a 2 comma 2 to the 2 square plus comma 2 to the power 3 comma 2 to the power 4 up to 2 to the power 10. This is a one sequence, and this sequence in a geometric progression. Okay, here it is a sum. Okay, now here the sequence 2 comma 2 to the power 2 comma 2 to the power 3 up to 2 to the power 10. See carefully, this sequence, okay, is in geometric progression with first term is 2 and common ratio is also 2. Okay, 2 square upon 2 is 2 cube upon 2 square, 2 to the power 4 upon 2 cube, it is common ratio, it is 2. And see carefully here, 2 is a greater than 1. Okay, then we know that it is a Sn is equal to A into r to the power n minus 1 upon r minus 1. It is a formula for r is greater than 1, and therefore this sum three into 2 to the power r, okay, can be written as here 3 as it is. Okay, 3, and here it is a sum of the 10 terms which are in a geometric progression. With first term it is a 2 and common ratio is 2, and sum is this, that is a S10. It is what? It is a S10 with A is equal to 2 and R is equal to 2. Okay, then this sum can return, it is a 2 into 2 to the power 10 minus 1 upon 2 minus 1. See carefully this. Okay, here there are the 10 terms, so it is a 2 to the power 10, n becomes 10. It is a 2 to the power 10 minus 1 and upon 2 minus 1, it is r is a 2 and a is also 2. Now we calculate this. It is a 3 into, it is a 2 minus 1, it is 1, so this can be written, it is a 2 into 2 to the power 10, 2 to the power 10, it is 1024 minus 1. Okay, and now it is 2 into 3, it is a 6 into 1023, and then the calculation is 6 into 3, it is 18, carry 1, 6 into 2, 12, it is a 3, again carry 1, 6 into 0, 0, it is a 1 and 6. Okay, here it is a sum of this term 6138. See carefully the calculation. Okay, here it is a sum of the 10 terms in a geometric progression. Here we find the S10, it is a Sn. Okay, here we find S10 because these are the 10 terms, r is equal to 1 to 10. And same calculation as the second example. See carefully this, the second. Okay, here it is sum r is equal to 1 to 10 of 5 into 3 to the power r, then 5 into summation of r is equal to 1 to 10 3 to the power r. Okay, same calculation. Okay, then it is a 5 into, when r is equal to 1 it is a 3, plus when r is equal to 2 it is a 3 square, then plus 3 cube, plus and so on up to 3 to the power 10. See carefully this calculation. Okay, when r is equal to 1 it is a 3 to the power 1, it is a 3. When r is equal to 2 it is a 3 square. When r is equal to 3 it is a 3 cube, and it is a summation. Okay, sum of the all terms where r is equal to 1 to 10. Okay, last term it is a 10. Again here it is a series, but sequence it is a 3 comma 3 square comma 3 cube up to 3 to the power n in a geometric progression. With first term it is a 3 and common ratio is also 3. Now here sequence 3 comma 3 square comma 3 cube up to 3 to the power 10 is in geometric progression. With first term it is a 3 and common ratio is also 3, and again it is a greater than 1. Now we know that Sn, here we find the S10 because these are the 10 terms. Sn is equal to A into r to the power n minus 1 upon r minus 1, where r is greater than 1. This formula for the r is greater than 1. Okay, now it is a sum of the 10 terms, so we find the S10, that is A into r to the power 10 minus 1 upon r minus 1, and therefore this summation, it is r is equal to 1 to 10, 5 into 3 to the power r is equal to, see carefully, it is 5 into S10. Okay, here it is a S10 where A is equal to 3 and R is equal to 3, and then it is here 5 into A 3 into 3 to the power 10 minus 1 upon 3 minus 1. Okay, and now the last calculation, it is a 2 and 5 into 3 it is a 15, therefore it is a 15 upon 2 into 3 to the power 10 minus 1. Okay, here 2 to the power 10, it is a simple calculation, that is 1024, but it is a 3 to the power 10. Okay, it is difficult calculation, so it can be written as it is 3 to the power 10 minus 1. Okay, here it is a second example and it is the answer for the first example. See carefully, check the calculations. Now the next example, here example number 12. The value of house appreciates appreciates 5% per year. How much the house worth after 6 years. After 6 years, if its current worth is 15 lakh. Here the given values for this example, it is 1.05 to the power 5 is equal to 1.28 and 1.05 to the power 6 is equal to 3, 4. Okay, now here see carefully this example. Here the value of house appreciate 5% per year. Okay, 5% per year. Okay, and here how much the value, how much the house worth after 6 years if its current worth is 15 lakh. Okay, current worth is a 15 lakh and 5% increases per year. Okay, current 15 and then 5% after 1 year. Then again here first worth it is a 15. Okay, then here it is a 15 plus 5%. Okay, again it is a second, again second value it is this, and then 15 plus 5% of 5%. Okay, it is a third. Okay, म्हणजे सुरुवातीला 15% it is 15 lakh, then 5% of 15 lakh, then here increase 15 lakh पेक्षा थोडं जास्त increase होईल, then obtained value again increases by the 5%. Okay, now like that it is a increases. Okay, increases by year by 5%. Okay, here and this increase, okay, we want to find the after 6 year. Okay, after 6 year first it is a 15, then the second year, then third, fourth, fifth and sixth. Now that means we want to find the 7th term, but the sequence form a geometric progression or the arithmetic progression. Okay, see carefully here. It is a geometric progression. It is a appreciate 5% per year. Okay, ratio. Okay, ratio वाढायला 5%. Okay, म्हणजे इथं काय येणार geometric progression. Okay, exact constant value increase होईना झाली. इथं काय होईल 5%. Okay, म्हणजेच तुमचं सपोज 15%, 15 it is a first, then it increase by 5. It increase by 5 lakh. Suppose, okay, it increase by 5 lakh per year. That means it is a 20. Then again 20 plus 5, again 25 plus 5. It is a arithmetic progression. But here not a constant increases of 5 lakh. It is a 5 lakh, not a fixed. It is a 5%. That means here it is a ratio is given. So here it is a geometric progression. Okay. Now here it is a current worth. It is a 15 lakh. Okay, it is the first term, but first we write the, it is a geometric progression. Okay, now the value or the worth of house appreciates 5% per year. Okay. That means it form a geometric progression. Okay, geometric progression, and the first term it is a 15 lakh. Here the current worth is current worth of the house is 15 lakh. That is the first term A is equal to, it is a 15 lakh. Okay, A is a 15. Now the common ratio and the R is equal to, see carefully, if the worth of the house does not increase, that means there the value of the house is 15 lakh, then 15 lakh, 15 lakh, after 6 years it is also 15 lakh. If it is a constant, that means the ratio in this it is 1. Okay, ratio it is 1, but it increases by the 5% per year. That is 1 plus, it is a 5%, that is 5 upon 100. It is a ratio for the increases. 1 plus 5 upon, it is 100. That means 1 plus, it is a 0.05. Okay, and that means 1.05. It is a common ratio for the increases of this. Okay, that means R is 1 plus 5 upon 100. That means 1 plus 0.05, and it is 1.05. it is a r. And now we want to find after 6 year. First term it is a 15, then first year, second, third, fourth, 5, and it is a 6. That means it is a term 1, term 2, term 3, term 4, term 5, term 6, and it is a term 7. After 6 year, that means we want to find the 7th term of this geometric progression. Here we want to find the worth after 6 year. That is 7th term in geometric progression. Okay, and therefore it is a T7 is equal to A into r to the power 7 minus 1, that means 6. Okay, the formula for the nth term. Here Tn is equal to A into r to the power n minus 1. Okay, T7 is equal to A into r to the power 6, and A it is a 15, and here r it is a 1.05 to the power 6, 1.05 to the power 6, and the value of this term is already given in the example, and then it is 15 into it is a 1.34, and now we calculate this multiplication. Okay, simple multiplication. 15 into 4 it is a 60. Okay, 0 carry 6. 15 into 3 it is a 45, that means it is a 51. Again carry 5. 15 into 1 it is a 15, and plus 5 it is a 20. Okay, and here 1 2 decimal point after 2. Okay, here that means after 6 year the worth of the house is 20.1 lakh. It is the last answer. Okay, write in the verbal. After 6 year the worth of the house is 20.1 lakh. Okay, write in the last the answer of this question. See carefully this. Now the last example. Example number 13. If one invests rupees 10,000 in a bank at a rate of interest 8% per year, that is a per annum. How long does it take to double the money? By compound interest. Here the given value, it is a 1.08 to the power 5 is equal to 1.47. Okay, now here given that the one invest of 10,000 rupees in a bank at the rate of interest 8%. Okay. Now the question is, how long does it take to double the money? That means our principal amount, it is a 10,000, okay, and the rate of interest, it is a 8%. Our amount, it is a 10,000, will be 20,000 in how many years? Okay, here see carefully, that is 10,000, and how long it take to double the money by using the here compound interest. Okay. Now here first the principal amount here given principal amount it is 10,000, that is P is equal to 10,000, and a rate of interest is 8%, that is R is equal to 8. Okay. Now let consider the n years will be take the money double. Okay, the time will be n years. Okay. Now let we consider, let after n years the money will be double, that is rupees 20,000. Okay, and now the amount, the formula for the principal interest here, the amount after n years is equal to, see carefully this formula, it is a P into 1 plus R by 100 to the power n. N it is a year, R it is a rate of interest, and it is a P is a principal amount. And here amount after n year, and we consider the amount after n year, it is a 20,000. 10,000 it is the principal amount, and double it is a 20,000. That means this amount, it is a 20,000 is equal to P, it is a 10,000 into 1 plus R, it is a 8 upon 100 and to the power n. Then this 10,000 will be, it is division, therefore here it will be 2, and it is 1 plus 0.08 to the power n, and then it is a 2 is equal to 1 plus, it is a 1 plus, that means 1.08 to the power n. Okay, here 2, that is a amount, we want to find the value of this n. Okay, then it is a 2, and it is 1.08 to the power n. We want to find this power. Okay, that means when we calculate, when we take this is 1, it is a not 2. Okay, when we take it is a 2, 3, 4, 5, okay, like that. Here the given value, it is 1.08 to the power 5, it is 1.47, okay, and 1.47 is not equal to 2. Okay, here that means we have to calculate the power more than the 5. Okay, more than 5 we calculate the 6, 7, 8, 9, 10. Okay, the 10 calculation it will be easy. Okay, here is the 5, given that the 10. Now we find the 1.08 to the power 10. See carefully, because 1.08 to the power 5, it is 1.47. Okay, when we take here 4, it is a less than, this is this value, it is a less than 2. Okay, 1.47. Okay, we have to near about 2. Okay, here 1.08 to the power 5, it is 1.47, but this value not near about 2. Okay, we can find the other value. Okay, 1.08 to the power 6, 7, 8, 9 or 10. Okay, the 10 power 10, it is easy to calculate. Okay, see carefully. Now first we check 1.08 to the power 10, it is a near about 2 or not. Okay, now see carefully. Here it is a given it is a 1.08 to the power 5 is equal to 1.47. Okay, now 1.08 to the power 10, that means 1.08 to the power 5 square, this value. Okay, and that means 1.47 into 1.47. Okay, that is the square of this term. Okay, 1.47 square. Okay, now we find the square of this 1.47 by rough calculation here. 147. Now here 7 into 7, it is a 9, that means carry 4. 7 into 28, that is a 32, again carry 3, then it is a 10. Okay, now it is a 4 into, it is 8, carry, it is a 2, that is 4, again it is 8, carry 1, 4, 5. Okay, now again it is a 7, 4 and 1. Okay, it is a square of 147. It is a 9, 0, and then it is a carry 1, it is a 6, again carry 1, 5 plus 5, it is a 1, and it is 2. Okay, now the square of this term, it is 21609, and the decimal point after 4 here. Now it is a near about 2. Okay, here it is 1.47 and 2.1. In the both two numbers, it is a 2.16 and it is a 1.47. It is a 2.16 is near about this 2. So approximately after 10 years, the amount will be double. Okay, therefore from this, it is a 2 is a near about 1.08 to the power 10 from this calculation. Okay, here from this we can write this 2 is a near about 1.08 to the power 10, and therefore after 10 years amount will be double. Okay, see carefully this.